This video is brought to you by Somewhat Angry Viking Man with Horn Helmet. Also, here's this really cool, I don't know what's going on with here. It's a scarf. I'm sure he would be upset that we called it a scarf, and a nice sword. Might be a kingish sort of situation. You may recall from a prior video, I called this man our Viking king. That looked kind of sad. I mean, he had the full beard and mustache. This man has got like the handlebar thing going on. So, yeah, Viking themed for compound interest. Okay, in this section, in this portion of the video, we're going to look at what happens when we compound more often than annually. And this is the more common type of compounding. For example, it's what you're going to see happening on all of your savings accounts and your credit cards. A pretty common one is quarterly. Actually, the most common one, I think, the savings accounts is monthly. So our author takes us through looking at quarterly, and quarterly corresponds to something being compounded 4 times per year. So we're investing $600 again. We're stuck on that at 5% interest. And what happens is when we do this 4 times per year, we take a fourth of that 5% interest and add it into the account a fourth of the way through the year. So if you think about a year being 12 months, and we figure out what's a fourth of those 12 months, it would be 3 months into the year, you would get a fourth of that total interest. Well, that's this calculation here, 600 times 1 plus the 5% divided by 4. There's another way we could do this. Remember, we knew that 600 times 1.05 equaled $630. Boy, I don't want to do this one in my head. It was really, there was that $30 of interest. We were going to divide that by 4. Let's see if we cut that in half. Divide that by 2, we get $15 per divided by 2, and then that divided by 2 is $7.50. Okay, so what's going to happen is they're going to give us $7.50 in the first 3 months. And then in the next 3 months, we would be adding on to this another fourth of that interest, but we're going to increase our account balance by the $7.50. So in other words, this balance here would be $607.50, and then we're going to multiply that by 1 plus 0.05 divided by 4, and this would be 6 months in, or half a year in. Oh, that's what we're supposed to do in number 1. So after 6 months, write a calculation that describes the future value using the same idea. We'll recall future value is A equals P times 1 plus R to the T power. And what's happening is we're going to do this one twice. So we've got 600 times 1 plus 0.5 divided by 4, and then we're going to do a second one of these. Of course, remember, when you're multiplying by the same thing repeated amounts of time, that means we can simplify that by using an exponent. So we're just going to square this. And I'm going to scamper to Desmos on this one. That's tough to do in your head. No shame in using a calculator, in my opinion. So we're getting 615 and, oh, let's say 9 cents. Okay, so what happens if we continue that process until the full year is up? Well, if we're doing it 4 times, we would have calculated this 4 times. And so the total exponent in the parentheses would be a 4. In other words, we would have written 600 times 1 plus the 5% interest divided by 4 raised to the 4th power. That would be the calculation. If we did this monthly, that means each month we would be adding in a portion of the interest. So we take the 5% divided by 12 and then dump it in at the end of a month, and then repeat and repeat and repeat. After 5 years, we would have done that 12 times per 1 year. After 5 years, we would have done it 12 times 5 years. We would have done it 60 times. We would have had 60 deposits of interest. And then generally speaking, if we did it n times per year, After t years, we do n times t compounds per year, and thus we're going to arrive at a new formula, which he's asking us to try to write it here, as he just gave it to us right here. Like, why would we do this mess? So it's the principal times 1 plus the rate divided by the number of compounds per year raised to the number of compounds per year times the time. We can add this to our list of things back from 3.1, our list of letters, IPRTA. This new one is N, and the units on this is number of compounds per year. Which is, this per year bit needs to be matching with our interest rate of a % per year. So those two do need to match up. Okay, so how does this mess work in practice? Well, let's take a look at problem 6. This is page 275. We're going to find the future value of the same $600 at 5% interest, but it's compounded monthly. And then we're going to compare that to an interest amount compounded daily. So we've got to do two calculations. I'm going to introduce you to a mathematical concept called subscripts. It's a way to show that two things are different. So I want to use this same A to represent future value. I'm going to put a subscript of M on this to say, hey, I'm calculating the future value on the thing that's compounded monthly. So my N here is 12. My P is 600, and my R is 0.05. Note that we're going to do this for 1 year. Kind of boring, but whatever. So it's 600 times 1 plus 0.05 divided by 12 raised to the 12 times 1. We'll smash that in Desmos and get what that number is. And then for the compounded daily, I'm going to use a subscript of a D to say, hey, here comes the future value for a D. Really, if I'm consistent, I should put M's on all of these letters here just to say all of these parameters go with this A subscript M. And then over here, it turns out that the only difference here is this ND, the compounds daily. This is a 365. Everything else is the same. The principal is 600. The rate is 0.05. And the time is 1 year. So I didn't really need the subscript here because they're the same. Okay, let's smash this in Desmos and see what the results are. The goal, of course, is to determine how big of an effect is the extra compounds. Like if we're depositing amounts of money more often into our account and then earning interest on that interest, does it have a huge effect on the amount of money, on the growth of the account balance? And you can see it doesn't. After 1 year, there is a couple cents difference between the two. So for the compounded monthly, we ended up with, let's see, $630 and about 70 cents. For the compounded daily, we ended up with $630 and 76 cents. So roughly a 6 cents difference after 1 year. Not a huge effect. Hopefully you can see why. What's happening is when we're depositing money 365 times into your account, the amount of money that's going in there is just really tiny. It's fractions of a penny that then we're earning interest on. So it does accumulate and have an effect. It's just not a large effect between the two. And that's our general conclusion here. Compounding more often per year has a small effect on the future value.